can verify the Pythagorean theorem. The P theorem, as I like to call it, is a squared plus b squared equals c squared. Both a and b are your legs, or the sides that form the right angle, and c is the hypotenuse, which is always the longest side. Now here, I'm looking at one side, which is 3, and then squared. 3 squared is 9, 3 times 3. And 4 is the other leg, squared. 4 times 4 is, of course, 16. And that must equal the hypotenuse squared. So 5 is your hypotenuse, and that is equal to 25. If you add the 9 plus the 16, you get 25. Now this says which equation is verified by the graphic below. So first of all, you know that to have the P theorem, you're going to have some squares somewhere. But I'm going to look at it and show you how I would attack this. First of all, I'd look at the shorter side. 1, 2, 3, 4, 5, 6. So I'd look for something that had 6 squared in it. Well, there's a 6 squared. And here's a 6 squared. So one of those maybe. Then I'm going to try the other leg. 1, 2, 3, 4, 5, 6, 7, 8. Well, this has an 8 squared, and so does this. But the problem is it should be leg squared plus leg squared equals hypotenuse squared. And this has the hypotenuse over here being added. Let me make sure this is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my thought is C is the answer, but I can always verify it. I'm going to do 6 squared plus 8 squared. And then I'm going to go to my next line and I'm going to type in 10 squared. Sure enough, those two numbers work, so that is correct. A lot of times if you get confused, just put these things in your calculator. 6 plus 8 does not equal 10, so that can't work. And I can tell you that the square root of 6 plus the square root of 8 definitely is not the square root of 10, but you can always put it in your calculator to prove it. And then finally, this is not true either. So this is the only one you could put in your calculator and make sure that it's true. There we are, stopping again.